So, today we are finalizing our SLD. I want to open another SLD for my client, which I have prepared. Okay, okay. SLD. This one, the PDF, I think is not good. I should open. Oh, what happened? Can you see the screen right now? So, Flex.
Yes, I see it.
Okay. Okay. Yesterday we start building a SLD in which I have just given the 10 strings per inverters and 18 PV module in one strings. And I have just like connected to the DC like the bus bus bar like the MPPTs. And then we have connected the five inverters on one bus bar. But at the same time, we have to give the uh, one breaker in that. So I will just adding the breaker in that. So what we will do, like this is basically the SLD we have prepared, and I have just like control shift copy. I have just the simple available in my laptop, so that's why I just go that just scale up here. Trim that file PL. So here I have just mentioned the breaker in that. Cut that. Okay. Excel horizontal, and then this one. ER frame.
We don't see anything, sir. Listen.
Okay. Here. Now I have added at also we need a breaker because when we are the breakers and other things, PL and same one like that. So here is the breaker available there. Then the transformer uh, place the breaker there. Okay, and just do that. This is so I'm just explaining how our will show like that. Here, just I will show you uh, if there are the multiple MV station there, like we have prepare a layout like that. Like that, we have two MV station there. So we have to combine these MV stations, the string inverter connected to these MV stations, switchgear, and then from switchgear to the MV station, there the transformer, and then transformer to the uh, to the MV switchgear. This MV and from this MV station output to the switching station are the POC power point of connection there. So this is basically how we will connect our loop there. Transformers, but I have prepared a one SLD for my client, and I will show you how we will these are the and the total DC capacity connected to that the 35 3.5 to 3 MVA megawatt. So we have connected to the directly connected to the MPPT of that inverter, and then we have combined these MV station to that switch gear. So basically it is the overall this which is I'm just showing there. This is basically the container solution. We have mostly you have seen that number in the large scale project, like I will show you one large scale project in Pakistan. Google map there. So it is just opening. It is just we will discuss this one the later. So is the full container. In it, the low switch gear available there, and then the transformer and ring main unit available. So here it is outside the container solution. We just connect these cables to the breakers, MCC breakers available, like 320 ampere of 400 ampere breakers are available. So here is the level there, and then from bar to the bar, it should be one breaker there. And also there are the this is basic CVT available, 250 ampere, 50 kilo amps per second is a breaker, and then the SPD available, 12.5 K limited, AC SPD type 1, type 2. So it is the SPD surge protection device available. Then the ACB air circuit breaker is available there. The main circuit uh, auxiliary system available. Auxiliary mean that we have to the this side of the low voltage side of the inverters, the primary side of the inverters. We have just uh, connected the one breaker, the 100 ampere breaker, 3 pole, and this is the fuse available. So just transferred to 400 kVA transformer there. So this is basically the star side. From okay, I will like continue my class. So here is basically the star type, and this is the delta type of the transformer. And we have connected the auxiliary system like the lights and the loads available there. It is also available in that MV station skid or container. Here is the class PT. This one the CT available, and this also the PT available there. So here is the 3000 by 1 ampere TT available, 0.4 kV, and it is also 8/100 volt PT available there. And this is the main transformer there available, which will connect basically the 800 in the star connection, and this will convert into the delta. Basically, we will just connect these, but they are neutral. We don't use that one. We just connect the three available. And from that one, they will just convert it into the NV switchgear side. Here is available SVI. This is the indicating lights available. That indicating lights available. And then the available and then and then the isolator and R switch is available, and then VCB. Here is the VCB circuit breaker is available in the main MV switch gear, the RMU side. So here it is the bus bar available, 33 kV bus bar there, and we have two terminals. One is for the input and one for the output. In the input side, like here. Input side, it should be the surge protection device available, surge arrestor available, the lights available, and then the R switch is available, and with the LBS, three load break switch available there. But for the output of the cables, for the loopings, just surge arrestor and lights available. No break LBS is available in that. And we just connect these output cable to the input of that another transformer available there. We have just loop in, loop out, and then this one also connected to that one another transformer, and then from that one this transformer we just connect to the 33 kV switch gear. It is available at the switching station there. So basically it is 33 kV switch gear available. It is also the three like the panels available, MV switchgear panels, and then we have another panel, output panels available there, 33 kV available, and that should be like connected to the transformer, which convert the 33 kV to the 63 kV available there. So here the R transformer available there. So the purpose is that last night Mr. Khurram has questioned that can we prepare this type of panels, but if I will prepare the panels there, it will just take too much time. So that is why to the my purpose is to give the understanding to everyone that how our system will work. That it is the basically the switching substation 33 kV available there. We have the auxiliary transformer. Basically, the purpose of the auxiliary transformer is that in the switching station or in the MV station, there are the multiple lights available there and other things available. We have to just convert that power available on MV stations or switching station to step down that transformer and connect to our lights and auxiliary load. When we are doing an understanding and our PVCist lecture, and I will explain that how we will put our auxiliary loads there. So that is the purpose for my understanding how we will do the this station there. So another transformer there available. There are the three transformer available. We have just connected the 11 inverter there, and then we combine into the one bus bar, and then bus bar connected to the main air circuit breaker there, and then air circuit breaker is connected to the transformer, MV station transformer. They will step up the transformer from 0.8 kV to the 33 kV transformer, and then their output should be passing through the VCB, vacuum circuit breaker, and then they combine on the bus bar, and the bus bar, the 33 kV bus bar there in RMU is available there. We have two terminals. One is for the input and the other is for the output terminal. Input should be left black in the first transformer, but the output should be connected to the input of the other simultaneously place the transformers, the loopings there, and then the output of that transformer to the input of the next one transformer, and then from the next one transformer we will connect the this transformer to the 33 kV switchgear, which is available in the switching or substation area in the PV area, and here we have the auxiliary transformer. They are available, and then from the output panels there 33 kV, and then they connect to the transformer of the 33 kV, and they step up their voltage to the 33 to 63. 25 MVA transformer is available there. We just connect to the point of the connection. So the purpose of that, to give the understanding how our system will work in the large scale project. But for the short level, we just connect our solar system onto the low voltage side. But most of the industrial level transformer and most of the industrial systems we are installing, that they will require that we will terminate our solar system on the 11 kV in Pakistan. Most of the time I have seen that our system will be terminated to the 11 kV. So there should be the easy way. So what you have to do, just do that one. You have to just combine your input in one LV switchgear, like the 11 and the 12 and 13 inverter there, and then one ACB breaker and one output breaker will go and conduct through the that CTs and VTs to the transformer. The transformer will step up their voltage from like the 400 to 11 kV, or 800 to 11 kV, which should be the suitable to the companies. And then you will just connect to this breaker, the VCB breaker MV switchgear available there, and you just connect the output cable. So here, when you are just connecting the one MV transformer and to the switch, the main output, your POC panels of the client. You just don't need that upper portion. So you have just output cable of that breaker VCB, and you just lay down underground or in parallel, if the switching the terminal or POC panels are available there. You just go and terminate on that main bus bar of that panels, and your system will work properly. So here is the overview of that, how we will do our large scale projects in. Uh, so that is why my purpose is to explain the overall process how we will do, because I have delivered the 20 lectures in last 20 days, and most of the time I have explained every step in our solar system designing. So that is why I expect that today you are in that position, that when I will explain that lecture, so you should understand my points, how our system will terminate on the large scale systems like 11 kV and 33 kV or 132 kV systems. But if you are working in the international companies and other things, you have different department there available in your company. So most of the time, where I have just working, our scope of work is just up to that MV transformer, that MV transformer. So we just connect these switchgear, and then they will and we just do what we do. We just loop out that transformer and lay that MV cable to that switchgear. So our work is just up to that one. Here below we will do that one. For the substation area, our different team is working. For the protections like the CT, VT, and other things, and SCADA and other things, will do the another department like the secondary department and the communication department. So this is the way of working in the large companies and the large scale projects. So I'm just showing you the how our in Pakistan, you can see that it is this is. This is the Qaidiyazam solar power plant is available in Pakistan. Here is the 100 megawatt system is available. The 4 available. It's 100 megawatt available. You can one MV MV transformer there in that location and one in that location. You can see that these are the roads and these are which are talking about, which is the switching station. What will do the loop will loop out that and then to that location to that switching stations solar power 132 kV. So here is basically the general overview of the SLD, like the inverter, the string connected to the inverter, and then an inverter connected to that breaker to the bus bar, and then breaker through that transformer, and then this will be the VCB to that bus bar stations. Well, like when you are doing like the small scale projects, you will just do like that. So here is the overview of that SLD and the main panels. Now, I think I have delivered many things. Now it's time I will just discuss the main point you have seen in my lectures, and if you miss anything, you will discuss with me in that class because we have just 20 minutes available remaining that, and I want to discuss some discussion with you. So now you should you want to discuss anything, and if you want to give me the suggestions for the next batches. Mr. Flex, how will see you in my lecture? Have you understand? Have you get the knowledge in my lectures? What is your recommendations and any suggestions for the next batches?
Okay, thank you for giving me this opportunity. First one for to participate. You remember the issue I have. God bless you for that opportunity. The course is very well, but it can be good if before we begin the training to know the level for the students and to focus for projects if the students have already some skills to go through some projects, and I think that can be good if the students
Mr.
have a knowledge, for example, on PVCs, on SketchUp, on AutoCAD. If
Mr. Flex, basically the issue is that when I have starting that lectures, most of the students have just reached out to me that we are we are unaware of that. We are basic levels. We don't know about that software, and we don't understand that. So that is why we have to start from the basic level. And I have tried in my level best because most of the time I try to convey you to participate in that, but I have not seen too much the participations and their, and most of the time I have not seen any, like in the previous batches. In the previous batches, like the daily basis, they will some make the some drawings and other things, and they will share in the groups, and they will get the responsive from my side. But I have not seen too much participation from that batch. But I have I which I have from the previous one, in that batch I have too much improvement that I try my level best to like the focus everything. Like in the last class, you can see that I have just explained everything for the large scale project, how we will do like the looping and other things. Because if I will go for the project based designing, I can't explain every step of that software, because my training, basically the focus for that training to train the people requirement of that softwares.
Okay.
I think basically the purpose is that if you are suggesting me that if I have to go to the project based, then I will don't explain every point of the softwares, because you understand my point, I think.
Yes, I understand your point. I understand on that. And also, I can say I can give my thanks before for every question we ask in our group. You are quickly to respond for us. That is good also. And I think it's not finished for today. If when we have a issue, will come to our group. We hope will
Yes, yes,
respond for us.
yes, I am available.
Okay, that's all for my side.
From Khurram's your side, any review, any suggestions, any questions?
Yes, I have.
Yes.
My suggestion is this: consistency is more important in our lecture that are missing somehow. It's genuine, your health issue, but it's not important.
Basically,
And another is thing,
basically, brother,
yes,
basically, brother, I just want to clarify. Basically, the consistency, the issue of the health, because you have seen that in the last week, what I am struggling. That is why I have to
yes,
miss that one.
yes.
Because
But it's not a
you know
big
that
problem.
yes, you know that I am also as a like the design engineer, and I
Employee
have to like
also, yes,
yesterday I will leave the office at 8:30, because I have to deliver the some important deliverables, and then I have to like uh, uh, shift the class for the 30 minutes after that. So that is the like the reason, because I am not uh, available every time. I have to go to the office and other things, and I have to maintain other things, because it is my not a proper job. It is my just part times working, and you can understand like.
yes.
Any other?
I understand this. I understand this, and I'm appreciating the basics of PVCist, sketch, and also the for AutoCAD. I don't expect that software and basics. No, I'm unable to use all these terms and commands. In my future projects, and I do, and I will do.
That's great. That's great. That is the main
That
important thing.
uh,
That is the main
yes,
because the class missing and other things, it will be the part of the life and the will part of the course. And I have not just missed any class, like I have missed 4 classes. I can do like that. I will combine like the two hours classes. I can do like that, but it is my responsibility because I have take the money from your side, all of your side, and it's not a good sign for me for my future and other things to continue that process. So that is why I just do 4 classes like the same way, because you can see that we have to complete that course in the last week, but I have just shifted to the next week because health is very important. Money is not important things, and other things will be the part of the life, but the first things is my life and my health. So it is preferable. So when I feel that I
yes,
am
yes,
now comfortable, I'm comfortable, I will deliver my knowledge. Then I will do and start the lecture again. Because in the previous
yes.
days,
It's
I
appreciation.
can do, yes, I can do the lecture. But if I will just go and just some things I will tell all of you and just talk to all of you and just give the question answer and then okay ji, that's Allah Hafiz. I can do like that, but uh, 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 it's not a good thing as a morally and as a human being, as a Muslim. It's not a good thing. So that is why I shifted to the next week and do proper training to all of you, because you have pay to me, and you have like pay your a lot of money to
Hard-earned
me,
money.
and it's not a good things.
Yes, I appreciated this. You can
Oh,
responsibly deliver to us with all your circumstances, but you deliver as your responsibility as a human being and as a Muslim. You can deliver us, and we will follow all the rules. And when I feel any problem, I will contact you in the group or personally. Uh, I personally have more techniques learned, and also the basic that's I don't know. In our Pakistan, I have major projects is 500 and 750 kilowatt projects, and after that I will try to inshallah install of 1 megawatt plus to use all of these techniques inshallah by planning and executing.
that's great. That's great. So, guys, I will uh, 1 minute, Mr. Felix. So, I'm just sharing one Google form there in the link in the group. So, all of you have to given me the the feedback, and also you have to fill this form for the certificate of that uh, course. So you have to just give me the responses also, uh, the good and also the suggestions. I will mention both the things in that. You have to give me the response, like you have what you have gained from my side, and what your suggestion from what is your suggestion for the betterment of that course, because from the like 3rd week of that December, I'm starting the next batch. And from your side, if anyone want to join that course, you can refer me and contact to me. I will enroll them from your side, all of you side. If you like refer any person, refer any person, I will give them the special discount from your side, because you are uh, now my part of my family as a student. So if you uh, like give them or refer anyone, I will give them the special discount for that.
Okay, I will try that.
Yes, Mr.
Okay.
Flex.
Yes,
Okay,
sir.
Mr. Flex.
I don't know
Yes,
if I can share my screen.
yes, you can share. Okay,
Are you see it?
wait a moment. I'm not yet,
Not yet.
not yet, not yet. Yes, now it's
I have
okay, okay.
Yes,
Yes, I
is
can share. Yeah.
about yeah, when we need to put
PVC.
many sub array, how to do it,
Yes,
because
yes,
sometimes
you can do. Yes,
yes, how to put because is very good to have many sub array here, but
yes,
I
yeah.
don't know how to
Here,
do that.
here, yes, you can see that here is the plus symbol there above the
Yeah,
name. You just click
yeah,
that. You just click that. Okay,
yes, I
now
will
you can see
click.
that. Now you can see that the subarray 2 is created available. Now
Y-
you here subarray available there. You can change the name from that one. Like I will
Yeah,
here if any marking available.
yeah, okay.
Marking and control. Can I do like that?
But
Marking.
my question
Basically,
is, we
yes,
have
yes.
200 kilowatts. I
Okay.
need to have sub array here to equal for that power.
Yes, you can do that. That. How we will do? You have to like decrease the string from the PV array one, and then add these array to that subarray two. So the total power should be remain same. Okay.
Okay. Uh,
Like here you can see that in the global summary, the nominal PV power, nominal PV power,
yes.
414 kilowatt P. It is
Okay.
basically it is the nominal power. When you just delete or add the string there, it will be changes automatically. So when you do like that, you have to achieve that 200 kilowatt. When it should be 200 at that so should and your panel will be the same. Like how many subarrays? Like the 3, 4, 5. Maximum you can do eight subarrays. I think maximum. I think you can add eight subarrays.
Okay.
Yes. Any other point?
Not. That's all for today.
Okay, that's great.
Uh,
So I think it's a wonderful time with all of you. Most of the students have joined the classes, but not regularly join the classes. And I hope uh, you have a wonderful time with me. And inshallah, if you have any issue and if you need any help from my side, you can contact directly with me and also in the group. I will be available. But most of the time, student has contacted me like in the office hours, and I have unable to reply them properly. So I will give them in the late night and other times slots when I will be free. So I will okay, guys. I think it's good time with you all of, and hopefully, uh, Khurram, if you need any supporting, like in the installation of that issue which you are facing last week, you can
Yes.
when you come into the you should call, but you should call me on the number, not on the WhatsApp. Previously, when you call me, you have call me on WhatsApp, and my that mobile in have no data availability. So that where this so that way you should call me on my number. Okay, guys. Bye.
Okay, sure.
Inshallah.
Thank
Okay,
you.
that's great. Thank you.
Bye-bye, please.